All right. Function analysis, unit 3. We started by finding possible locations of maxes and mins. Today, we are going to discover and we are going to analyze and determine if at a critical point we do have a max or a min. Okay? And how we're going to do that is by looking at slopes, by looking at signs of slopes. Let's recall average rate of change, instantaneous rate of change, how slopes equal rates of change. And recall the translation of these slopes. Between A and B, I see the average rate of change is 1/3. The slope is 1/3 between A and B. I would say that on average, f of x, if this is f of x, goes up 1/3 of a y per x on the interval from A to B. Okay, it's how quickly it's moving up on average over that interval. Then we talked about tangent slopes tell you exactly how quickly a function is moving, whether it's up or down. So like at x equals b, f of x is going up 3 y's per x. Because the slope of the tangent of this function at b is 3. Then I kind of threw in another one here at c, at x equals c, f of x, since the slope is negative, I know it is going down 2 y's per x at that location. And the overall thing that we want to take away from this is that when a slope is positive, my function is going up from left to right. When a slope is negative, my function is going down. It's decreasing in its y values or increasing in its y values. Decreasing, increasing. We will see when. And I'm not going to sketch the tangent lines, but pretend like I'm sketching tangent lines here. When tangent slopes are positive here, tangent slopes are positive here, my function is going up. I'll use an arrow like this, saying it's going up, or it's increasing. Now, we're in America. In America, we read things from left to right. It is very important that in mathematics, we do the same thing. We go from the smallest x value to the largest in terms of most negative to most positive. So when we look at things going up, you don't start at the y-axis and say, oh, I'm going up, because that would be from right to left. I say from left to right. From left to right, I'm going up. So this is going up, this is going up from left to right. Left to right being very, very, very important, or else things are going to be very, very complicated for you guys. My tangent slopes are negative here. All of these tangent slopes are negative. I'm just going to do that symbol. We can see my function is going down from left to right. Use an arrow symbol for going down, or we could say it's decreasing. The y values are decreasing. We have a 0 tangent slope here and here. We are neither going up nor going down. We have flattened out, or we are constant. undefined, there's no points where it's undefined, but could mean a lot of things. When it's, throw this in here, undefined could be a sharp point, or no point. All depends. Or it could be a vertical tangent. Undefined are tricky. We won't have to worry about them that much. Okay? Now, in this class, and with students, we like to stay in the world of f of x. Okay? And f of x is increasing when its derivative is positive, when f prime is positive. We like to think of f prime as being the derivative. But we won't have to do it much this unit, but moving forward, and we will do it in this unit, it is important to understand that f prime isn't the only thing for a derivative, okay? Because I might be asking you about some other function v. And I ask you, when is v going up, or when is v going down? And you will look at when v prime is positive. Sure, it's still a first derivative, it's still normal. But I might be asking you, hey, f prime, what if this was f prime? When is f prime going up? Well, when its tangent slopes are positive. F prime would be going up when f double prime is positive. It's very, very important to not stay in the world of f prime as like what we get to. Because, and this is very, very, very important, something is increasing or going up if its derivative is positive, if its tangent slope is positive. Now, I'm not going to write is positive anymore. It takes too long. You are math students. You should know that something greater than 0 is positive. So like, sure, f is increasing if f prime is positive. But like, f double prime is increasing if its derivative is positive. See what I'm doing there? V is increasing when v prime is positive. V prime is increasing when v double prime is positive. Okay, we don't just necessarily stop at f prime. It all depends on the question. Something is decreasing if its derivative is negative. Instead of writing is negative, we know that something less than 0 is negative. Something is constant if its derivative equals 0. Okay? And this is important because being able to analyze signs of derivatives will lead me to discovering if critical points are maxes or mins. I don't know if this is in your notes, but put it in. Helps determine if critical points are maxes or mins. Okay? All right. What we are going to do, and we're going to like pretend like the graphs aren't there, but for right now. We understand that we have a min on a function when a function goes down and up. You know, this is a min. And let's say these are all f of x's, and these are critical points. Well, if my function goes down, then up, I know I have a min. Now, it might go down and flatten out, then go up. But it also, and kind of include this, could go down, end up with a sharp point, and go up. Still a critical point, its derivative is undefined. What we are going to be doing is, through an analysis of signs of derivatives, knowing that if this is f prime's sign, or f's derivative is negative, that tells me that f is going down. If f's derivative is positive, that tells me f is going up. We will produce this and will tell us that we have a min. I'll show you how we're going to do that later. For maxes, we see we have a max if we go up then down. And maybe we flatten out or we end up with a sharp point. Doesn't matter. Well, if we know the signs of a derivative are positive, I know my function is going up. If the sign of my derivative is negative, I know my function is going down. We will attempt to produce something like this given a function, and it'll tell me that I have a max. And it doesn't matter if at this critical point C, you are 0 or undefined. There will be situations where we will not change sign. We will flatten out. But this is going up, flattening out, then going up. My derivative signs will show me that they will be positive and then positive, with either a 0 or undefined in here. That will tell me that I'm going up then up. That will tell me that this is neither a max nor a min. And this is the same thing with like an undefined tangent slope. It'll be negative and negative. Okay, so our goal today is create these things, and then we will know, oh, we have a situation like this. If a derivative is negative, the original function is decreasing. It's going down. If a function is going up, its derivative is going to be positive. Okay? All right. Now, to be able to produce these things, these sign analyses, which are all we're going to be doing today, is our end goal today, we need to discover or figure out when something is positive or negative. Okay? When is something positive or negative? And I'm going to give you like a quadratic to think about. Here's a quadratic. Where do we have positive values and where do we have negative values? All right, well, let's look. Positive values are above the y-axis. Negative values are below, the x-axis. Negative values are below the x-axis. So here's positive values. Here's positive values. Here are negative values. What separates a positive value from a negative value? Discuss with your neighbors. What do you think? Zero. Zero is important. Go to lunch. Positive and negative values are what we're going to be analyzing, because understanding signs of f prime will tell us whether we have maxes or mins. What separates positive from negative things? Zeros. Are there any other situations where we might jump from a positive to a negative value? Think about it. Discuss with your neighbors. Are there any other situations where we might jump from a positive to a negative value? Like we pass through a 0 here, we jump from a positive or a negative value. Is there any other situations where we can jump from a positive to a negative value? What do you think?
I'll say like an actual jump.
A jump. Sure, a jump. We could have a jump. We could have a situation where I got some positive values and then I got some negative values. Okay? So a jump. Other situations where we could jump from positive to negative values. So if you're thinking about like the graph of an absolute value, then it is passing through a 0. So again, we're at 0. So good guess. But there is another situation besides a jump and besides just passing through 0, where we could jump from positive or to negative values. Anybody? What's another situation with a function where we could jump from positive to negative values, or vice versa? An asymptote. In an asymptote, we could jump from positive values to negative values, like that. So what separates positives from negatives? Either zeros or undefined values. Guess what? Critical points. We've already talked about how we've wanted to find when f prime was 0 or undefined. A big reason for that is because it is where signs can change, where we can jump from positive to negative values. Okay? Okay, so keeping that in mind, this is kind of like the connection between critical points. We are going to try to produce this given a function. So let's go to this really quickly. Okay, just skipped a little bit. I want to figure out not only the critical points, but are they locations of maxes and mins? So we're going to do what we've normally done from last lesson, is we're going to find possible locations where the signs of f prime can change. This is the possible locations of maxes or mins for f. We are going to find the critical points. We get x squared minus 6x plus 5. I'm going to factor x minus 5, x minus 1. And set that equal to 0. I get 1 and 5. Well, like, great. How do I know if that's going to be a max or a min? What we're going to do, the extra step now today, is we are going to produce a sign analysis. And we are going to focus on these locations at 1 and 5. And that will tell me the behavior of f, whether f is going up or down. We'll be told if f prime is positive or negative. Okay? Now, don't worry about that. We'll come back to that. How do I know if f prime is positive or negative? Well, if I know the zeros of all the points of a function, I will know that in between or outside of those zeros, all of my points are positive or negative. So I will start by finding the zeros. Let's go back. And throwing those numbers at on a number line, one-dimensional number line. And I'm going to look at the signs of f prime. Knowing that I found all of the zeros and all the undefined function values, I will know that f prime is either positive or negative in all these intervals. It's one or the other. Why can't it be both? Why can't I have some positives and some negatives between 1 and 7? Discuss with your neighbors. Why does it have to be either positive or negative? Why can't it be both? It would have to go through another zero. It would have to either go through another 0 or have an undefined value to jump from positives to negatives. So I know for certain it's either positives or negative everywhere. Well, guess what? Since it's positive or negative everywhere, all I need is 1 point. If I know the sign of one value in an interval, of one value between zeros, / undefined, I'll know the sign of all of the values. So what we're going to do is we're going to say, hey, plug in 8, plug in 3, plug in 0. What is the sign at those points in between your zeros and outside of your zeros? Because it's going to be the sign of all of our values there. Now, where do I plug it into? Will I plug it back into the original function f, or will I plug it back into f prime? We are trying to analyze the signs of f prime. So I want to plug it back into f prime. However, we have two versions of f prime. We have f prime and a factored f prime. I will tell you right now, it will be so much easier to plug values into a factored form of f prime than into regular f, because I know the sign kind of relationships of products. I know that positives times positives are positives. I know that a positive times a negative is a negative. I know that a negative times a negative is a positive. So if I plug in 8 into this, I don't really care what the value is. I just care about the sign. I'm going to just show you, like, yeah, 8 minus 7, and then 8 minus 1. But I'm thinking really positive times a positive. I'm going to have positive values to the right of 7. If I plug in 3, okay, 3 minus 7, 3 minus 1, that's a negative times a positive. I won't really do this. I'll just do this in the future. I know that I have a negative values everywhere between 1 and 7. To the left of 1, 1 minus 7, 0 minus 7, 0 minus 1. That's a negative, positives. Once I'm able to do that, I know, and I don't even have the equation for f, but like we're just assuming that its derivative produced this. I know the behavior of f. I know f is going to be going up because its derivative is positive. I know f is going down because if its derivative is negative. I know f is going up. After doing that, I will be able to say, oh, I go up, flatten out, go down, max. Oh, I go down, flatten out, go up, min. And that's how I'm going to be able to tell whether or not my critical points or maxes or mins. Okay? So, going back here. In this case, I gave you f. Okay, great. You found the critical points. Are they critical? They're possible locations of maxes and mins. It's when the sign of f prime might change. Great. Now, we will do our sign analysis for f prime by plugging in test points into our factored f prime. That will tell me if we have all positives or negatives in my intervals, and that will tell me the behavior of f. Go. Please check your sign analysis with your neighbors and tell me, is x equals 1 a max or a min? Is x equals 5 a max or a min? It's not about the values, the numerical values. It's about the signs. Plug in 6 into here. Plug in 6. 6 minus 5. I'm not going to write down 6 minus 5. I'm just going to kind of do in my head that 6 minus 5 is a positive. 6 minus 1, positive. Positive times a positive, positive. 3 minus 5, in my head, negative. 3 minus 1, in my head, positive. Negative times a positive, negative. 0 minus 5, negative. 0 minus 1, negative. Negative times a negative, positive. Because I know the signs of f prime, I know the behavior of f. I know f is going to be going up, and going down, and going up, because I know the signs of its derivative. That is telling me that x equals 1 is a max, and x equals 5 is a min. Okay? Now, it's not always going to be flip-flop signs. It's not always going to be positive, negative, positive. It all depends. Like, if I gave you f prime is equal to, and this is just the derivative, and I'm going to change it on you, negative 2 x minus 3 times x plus 2. Let's just pretend that I have a function. I took its derivative. I factored the derivative. Here is my factored derivative. Please set this equal to 0. And then do the sign analysis. I kind of set it up so that you can do the sign analysis right away. Just practicing the analysis of the signs of f prime. Make sure you put your zeros in order. That will help you. Make sure you include that negative 2. We went back a page. I'm skipping around here. Sorry. We did that. We're on this now. Right here. So be careful. If I plug in 4, negative 2, that's a negative, times 4 minus 3, positive. 4 plus 2, positive. Flip that. You don't have to write down numbers. If it helps you to write down numbers, great. But if I plug in 4, maybe with numbers one more time, I got negative 2 times 4 minus 3 times 4 plus 2. I don't care that it's negative 2 times 1 times 6. I care that it's a negative times a positive times a positive. That's a negative. Do the other intervals if you were wrong for the sign of f prime to the right of 3. if I plug in, say, 0, I'm not plugging in -2 or 3. Those are zeros. I know that. In between, I get -2 times -3 times 2. That's a negative times a negative times a positive. Positive. If I plug in -3, I got -2 times -3 minus 3. That's a negative times -3 plus 2. That's also a negative. Negative times a negative is a positive, times a negative is a negative. Because of that, I know that F has behavior of going down, going up, going down. Down to up means x equals -2 is a min. Up to down means x equals 3 is a max. Okay, so in this case, we want negatives, positives, negatives. In some situations, again, I'm giving you f prime. So it's like, I gave you f. This is like pretending here. I gave you f. You took its derivative. You factored its derivative, and you got this. Okay? So this is what you've done already, and you got to this point. You are now ready to do the sign analysis. You see that 2 and 3 and 4 are the zeros. Zeros meaning possible locations where we change sign. It's not always going to change sign at these locations, though. Okay? And this is an example of it might not change sign at a 0. So it can't be a situation where if I plug in like 5, positive, 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 okay, I know that's positive. Do not blindly just put those in there because it's not correct. Because you know that we have situations with zeros where we can just touch the x-axis and come back up. We do not change sign at that 0. We have situations with jumps where I could jump from a positive but stay positive. I have situations with asymptotes where I could stay positive. So not always when we have a 0 do we have a sign change. Just like I told you, not always at locations of critical points will there always be a max or a min. Let's do some work. Plug in 3.5, 2.5, 1. See where we don't change signs. I will tell you right now that we do not change signs at 3. I know we don't change signs at 3 by looking at f prime. Check with a neighbor once you think you have your signs down. Okay, so I have to keep track of these exponents because this negative cubed, okay, that's negative. When I plug in 3.5, I got a negative for the x minus 4 cubed. But this will be positive, this will be positive. When I plug in 2.5, first guy's positive, I'd have a negative value being squared. This is very important because that ensures I stay positive. Now I have a negative value cubed, well, I still have a negative. Well, that means the signs between 2 and 3 are negative. Going all the way to like 0 of negative 2 times a positive value because I'm squaring times a negative value because I'm cubing, that's a positive. We just figured out the behavior of my function f. I know what its shape is. It's pretty cool that by analyzing signs of derivatives, I know f has got to go up, it's got to go down, it's got to flatten out, go down some more, and then go up. We can think of f of x as having this type of shape, up, down, flattening out, down, up. What's fun is that we'll be able to graph f of x's after we've done an analysis and see like, yeah, I was right. This is the shape. This is what I expected to see, all through the power of calculus and knowing signs of derivatives. So what we will say is that x equals 2 is a max. We will say x equals 4 is a min. And I'd like you to identify 3 as a critical point, but as a location where you have neither a max nor a min. It is a critical point. It is when our derivative equals 0. However, we do not change signs there. So we have a situation where we don't have a max or min. We either flatten out or we have a vertical tangent or something like that. Okay, cool. We've already done one function all the way through. Let's do this function all the way through. All you guys. This is a function. Calculator, you will be able to determine the locations of maxes and mins on this function, as well as a location of like a neither potentially, where we flatten out but we don't have a max or a min. Do all the steps. Like last class plus this class, the number line sign analysis. Because signs of derivatives tell us if something is increasing or decreasing. Good. I love how I see everybody taking the derivative first. I love it. We understand what's going on here. We understand that in those previous examples I was showing you, I already gave you f prime. I've already taken the derivative and factored it. Good, good, good. So now we're doing this guy. Just plugging it into that guy. Nope. That, and that. Don't have to worry about the actual value. It's just positives or negatives. You forgot to take the derivative first. I'm sorry, I didn't catch you early. So the difference between these is that I already gave you the derivative. It's like I already had the function. I already took its derivative, and I already factored it to give you that. But this one, I'm giving you f, so you need to find f prime, and then factor, and then go. Okay, so since you pulled out x squared, it's just x minus 1. So that's just going to be 1. You will notice it would have been funky, like finding the signs for that situation. our critical points are just 0 and 1. So hopefully we got that. This is like a question that we would have had on our quiz today, finding critical points. The extra step today is our sign analysis. Once my cursor comes back, we'll do that. Plugging values, test points, into my simplified factored f prime around my zeros of 0 and 1, I'll be able to determine the behavior of my function. Plugging in, I like to start on the right. That's just what I like to do, positive values. Well, positive 2 squared, positive, 2 minus 1, positive, positive times a positive, positive. A half, positive, negative. Negative 1. Negative 1 squared is a positive. Negative 1 minus 1 is a negative. So this is another situation where I don't change signs. F is going to decrease, flatten out, decrease, flatten out, increase. I know it flattens out because I have a 0. I don't have a sharp point. I just have a 0. That means x equals 1 is an extrema. It's a min. x0 is a critical point, but is neither a max nor a min. Okay? You would be able to just sketch. Now, what's great, and we'll do this in the future, is that, you know, with a little bit of work and a little bit of y values, you can kind of see what's going on. Like 0 and 1, those are important points. Well, if I plugged in 0, I got 0. I know I have the point 0, 0 on this function. If I plugged in 1, I'd get 1 minus 4/3. That's negative 1/3. Okay, I got 2 points. I know I have 1 negative 1/3. I know I have 0, 0. Well, I know my function is going down, flattening out, going down, hitting a minimum, and then going up. Right? We just kind of threw that together pretty quickly. Here it is. Going down, flattening out, going down, hitting a min at negative 1/3, and going up. If I zoomed in around that 0, 0, we can see it even better. Goes down, flattens out, goes down, hits a minimum at 1. That location is negative 1/3, goes up. All through the power of calculus. It's really cool. Hopefully you appreciate that. All right. Been a while, but we got a quotient. We got to use the quotient rule. Your homework has all different other types of functions that, you know, like those square root functions that we kind of did a bunch of. You'll see those in your homework. Those are fun. Let's do this one. This is a quotient rule 1. The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay. Immediately, I know that this needs to be taken into account. When our denominator is 0, we are undefined. I have what I would consider a critical point at 0, but we'll discuss that in a little bit when we come back to it. Let's go ahead and solve this equal to 0. We know we just need to have our numerator equal to 0, if you remember from finding horizontal tangents. So I'm going to simplify. I got 4x to the 5th minus 2x to the 5th. Make sure you distribute the negative. Minus 2x. So 2x to the 5th minus 2x equals 0. Factor out a 2x. get x to the fourth minus 1. Phenomenal. I could factor this some more. It might be good if I do so. Might not be. But we will have 3, plus and minus 1, and 0. If I wanted to factor this more, I'd have x squared plus 1, x squared minus 1. And then that would factor to be x plus 1, x minus 1. I don't think it's necessary to go all the way down here. I think we will be able to work with this pretty easily, so long as we kind of understand fractions. So here we go. 0. Well, we already knew 0 was a situation we needed to worry about anyway, so that's good. Negative 1, positive 1. I know we are undefined at 0. I know I have 0 at negative 1. I know I have 0 at 1. 2. 2 times 2, positive. 2 to the fourth minus 1, definitely going to be a positive. 1/2. 1/2 times 2 is positive. 1/2 to the fourth. 1/2 times 1/2 times 1/2 times 1/2 is 1/16. We don't really need to know that. If you take a fraction multiplied by itself, it's just not going to turn into a whole number. If I subtract 1, that's a negative. I think that's a lot quicker than going and plugging in 1/2 into all of these, in my opinion. So I get a negative. Negative 1/2. 2 times negative 1/2 is a negative. Negative 1/2 to the fourth. The fourth power makes it positive, but again, it'd be positive 1/16 minus 1 is a negative. Aha, this is a positive. Negative 2, 2 times negative 2, negative. Negative 2 to the fourth, positive, minus 1, positive. Now, I neglected something. We should have also incorporated this x to the fourth. I should have looked at 2x over x to the fourth minus 1 over x to the fourth. However, I know this is always positive, so it doesn't affect the signs if I just looked at the numerator. Okay, cool. So, behavior of f, this is a little tricky, is down, then up, then down, then up. So, it looks like x equals negative 1 is a min, x equals 0 is a max, x equals 1 is a min. This is not true. And it's not because it's undefined, because you could have situations with sharp points, and we will see them, where sharp point is a max. I don't have a sharp point at 0, which is why I don't have a max. What do I have, and why don't I have a max at x equals 0? See if you guys can talk about it. Just so you know what you should look at. Anybody? It's not a max. Why? Look at your original function. Why isn't x equals 0 a max? I can square 0, it's 0. But you're right, f of 0 is undefined. What does that mean we have on the graph of f at x equals 0? An asymptote. We have a vertical asymptote. So we have to be careful. If we go back and look at our original function, we might be able to see like, oh, actually, yeah, this isn't a sharp point. We don't have a point at all. F of 0 is a location of a vertical asymptote. We had 1 over 0. That's a vertical asymptote. So that's why x equals 0 is not a max. I'll show you how great you guys did if I graphed x to the 4th plus 1 divided by x squared. There is a min at -1. There is a min at 1. We have a vertical asymptote at 0. It's really cool. We were able to do that. All right. Now, let's next level this type of question. Telling you to be careful. This is tricky. Here's a function. When is f prime increasing? And what's really important is, like, for all of these previous questions, I could have asked you, like for this one, when is f increasing? And you'd say, oh, f is increasing when f prime is positive here. And you would have said x is bigger than 1. Okay? So understanding that, you could have answered it here. When is f increasing? You would have said, oh, right there, between -1 and 0 and after 1. But I'm not asking that. I'm asking, when is f prime increasing? Got it. Keep your phones away if you're staying. What is f prime increasing? If you think, okay, f prime, 3x squared plus 6x equals 0, factor 3x, x plus 2 equals 0, 0 and 2, -2, okay, -2, 0, great, f prime, let's see, positive, 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 negative, positive, negative, 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 positive. Okay, here and here, you are wrong. Why? Not because of anything I did wrong. Like this is all correct steps. I did all the correct analysis. But why is this not answering the question? Because it's the behavior for f. F is going up. F is going down. F is going up. It's not about when f is going up. The question is, when is f prime going up? Discussing neighbors. What does that mean we have to do? Analyze the sign of its derivative. Its derivative, which ends up being f double prime, who cares? I'm just saying its f prime's derivative is 6x plus 6. That equal to 0, you get -1. You can factor out the 6 if you wanted to. Then, using -1, f double prime sign will tell you if f prime is going up and increasing or going down and decreasing. So, plugging in 0, 0 plus 6, that's easy enough. -2, -12 plus 6, that's easy enough. Because f double prime is negative, f prime is going down. Because f double prime is positive, f prime is going up. We would say f prime is increasing for x is bigger than -1. think about f prime increasing. The slopes of the tangents need to be increasing. So the slopes, f primes need to be going up. These values better be increasing. You can come in. All right. Trig functions. We'll have to deal with these as well. Go ahead. Now notice, I'm back to relative extrema, increasing or decreasing for f. Take the derivative, set it equal to 0. You could come in, Mr. Garcia. I just need to finish up this lesson. Okay. Got to know my trig. 1 is cosine equal to positive a half. 5 pi over 3. It will never disappear on you. Now, we have an interval, 0 to 2 pi. So we actually have a starting point and an ending point, or else this would go on forever and ever and ever. However, we could actually include values like 0 when we're doing a test point. Because like the next 0 or the next solution for cos x equals a half would be at negative pi over 3. So 0 is between pi over 3 and negative pi over 3. So I actually could plug in 0. If you're comfortable doing that, great, because this is not 0. This is a 0. This is a 0. Now, I don't have a factored form, so I need to go back to here. Now, again, why don't we plug in 0? Cosine of 0 is 1. 1/2 minus 1, negative. Since that's negative, I know everything's negative. You could also have done pi over 6. Cosine of pi over 6 is root 3 over 2. 1/2 minus root 3 over 2. Root 3 is bigger than 1, so 1/2 minus root 3 over 2, also negative. Between pi over 3 and 5 pi over 3, there's lots of good options. Pi over 2 is a good option. Pi, 3 pi over 2. I'm using pi. The cosine of pi is negative 1. You'd have 1/2 minus negative 1. 1/2 plus 1, positive. Again, after 5 pi over 3, if you wanted to use 11 pi over 6, you could have, but it's probably easier to use 2 pi. Cosine of 2 pi, just hang out, I'll be done in a little bit, is 1, 1/2 minus 1, negative. I find that x equals pi over 3 is a min. X equals 5 pi over 3 is a max. And for fun, let's look at what 1/2 x minus sine x looks like. Okay, it ends up being like tilted a little bit. We can see I have a min at pi over 3. I can plug in pi over 3. And there is a min. If I plugged in 5 pi over 3, I have a max. Okay, cool stuff. All right, let's pause for a second. All right, to make sure we really know what's going on, you're going to be given these types of questions. Well, you're not given a function, and you're not taking the derivative, setting it equal to 0, blah, blah, blah. You're going to be given graphs. And you're going to have to interpret and analyze the graphs to be able to answer the questions. Now, pay attention, because this is tricky the first time you do it. You are asked questions about F. Where are the critical points? Where are the relative extrema? You are not given F. You are given the graph of its derivative. Okay? So, when I ask students questions like this, right off the bat, I ask you, oh, what's the relative extrema of F? They're like, oh, there's a maxa. It's x equals -1. And in there a minute 2. No. You're not thinking about it the right way. Okay? The signs of F prime tell us the behavior of F. The value at -1 is positive. F prime at -1 is positive. F is increasing at -1. Positive values, negative values. What we're going to want to do, and what I'd recommend, is translate this two-dimensional graph into a one-dimensional sign analysis chart like we've been doing. And you'll see you have zeros. Zeros are your critical points. It's where you possibly could change sign. These values are negative values. Yeah, they're increasing values, but that's not it. The slopes of F prime is something different. The values are negative. The values between these two zeros are positive. The values between these two zeros are negative. These values are positive. It is from this analysis that we know that the original graph F, which is not shown to us, is going to be going down, going up, going down, going up. And it's not -1 and 2, it is -3 is a min, 1 is a max, 3 is a min. For F, and that's what we've been doing all along, is like we've been analyzing F prime to talk about the maxes and mins for F. The critical points are at those 3 locations where we have these zeros. Let me just make sure we go back. For all these questions where I gave you F prime, I forgot to do we had a max and a min, not for F prime, but for F. F. Given F prime, we find maxes and mins for F. Okay, cool. See, you can tackle this guy. Where are the critical points for F? What are the locations of the relative extrema for F? These are positive values of F prime. These are negative values of F prime. Sides of a derivative tell us if something is increasing or decreasing. Okay, the next one is very similar. The only difference is they ask you kind of different questions, like when is F increasing? When does F have relative maxima? Make sure you read the question carefully. Relative maxima just means we want locations of just maxes. So we read the question carefully, we say maxes. F increasing, we should think something is increasing when its derivative is positive. So when I do my sign analysis, focusing on my critical points where we have possible sign changes, I see F prime goes from negatives to positives to negatives to positives. That means F is going down, then up, then down, then up. Where do we have maxes? Just here at x equals -1. Where am I increasing on the graph of F? F is increasing when F prime is positive. That is there and there. So we'd say from -4 to -1 and 4 to infinity. That's one way of writing it. You could say x is between -4 and -1 and bigger than 4. That's another way of writing it.
You put the greater than equals for greater than or equal to symbols for -4 less than x, which is less than -1.
It's a good question. So I say that at -4 we are constant, and at -1 we are constant. So I would not include these values. So that's why I have the open brackets, and that's why I am not having a less than or equal to. Because I don't think we're increasing or decreasing at -4 and 1. Okay, a couple more, real quick. What's different about this graph from the previous ones, again, this is the graph of F prime, is that 1 is one of those situations where we have a 0, so we have a critical point. Sorry, 1, we have a 0. But we don't change sign. We change signs at -4, but we do not change signs at 1. This is F prime. This is telling me F is going down, going up, flattening out, and going up. 2 critical points. But we only have one extrema. X equals -4 is a min on the graph of F. All right, and we already answered this question. Where does F have relative minimum? Well, again, doing your sign analysis, -4 seems to be a popular number. Negatives to positives. I got a sharp point at 1. I don't really care. It's still a positive value. I switch to negatives at 3. Leave a relative min when I go from down to up. That's at x equals -4. When is F increasing from -4 till 3? That's when F prime is positive. And don't include that 3. What type of point on f of x is x equals 0? Do you guys have this one? All right, good. Skip it. This one. Uh-oh. Yeah. Uh-oh. I don't know why I'm doing this. There's a jump on f prime. What does that make f prime of 2? What would you say f prime of 2 is? Undefined. Does f have a critical point at x equals 2? Critical points are when the derivative is 0 or undefined. So, yes. Does f have an extrema at x equals 2? Yes or no? Why? Why not? Anybody? No. Yeah, that's what most people think. The answer is yes. Why? Well, what could happen at an undefined location? We already looked at one situation where you could have a vertical asymptote. But notice, f prime's negative and then positive. It's positive between -1 and 2. It jumps down to negative values after 2. I got a 0 at -1. I'm undefined at 2. At 3, it's got a 0, goes to positive. At 5, it goes to negatives. Is there a situation where your derivative is undefined, but you have a max or a min? What does it look like? Not enough. So we already saw something like an asymptote, which means I didn't have a function value at all. But I might have a function value. I'm going down, I'm going up, undefined, going down, going up, going down. Going up, undefined, going down. I can have a sharp point. If you have a jump like this, that's an indication that you have a sharp point. Okay? So, yes, x equals 2 is a max, and it's like having a sharp point at 2. If you ever see a jump, sharp point. If you see an asymptote, that'll be an indication of an asymptote when you look at your graph of f prime. We have a min at -1, a max at 2, a min at 3, a max at 5. All right, last one's tricky, which is why I put it on there. Thank you. Make sure you do your homework.